Hello, it's Loop Darksnow here with the third last episode of BackBit Impossible. And in this one, well, I've got another color unpacker to show you here. In this episode, I get it working and it doesn't work the first time, so I got to debug it. And then there's a bug that kind of warrants the name of this episode. So, it helps keep the story together. Anyway, so yeah, now you know everything that's in it. So let's watch it. All right. Okay, I have not made a video in a few days here. I'm jumping it back a little bit for you guys just to show you where I was. I was in I guess it's a slump of sorts. I was running into this bug because I have a new color unpacker because my previous one wasn't fast enough, right? I needed something a little more creative. And perhaps I'll break in right now and show you how it works versus the old one. Okay, so this here is a section of the color unpacker. This little bit of code only deals with 1/8 of the color RAM. It's self-modifying code that's set by depending on which buffer you're dealing with and stuff. Anyway, we grab a byte, and if it's positive, we loop back using that as the new place to grab data from. So that's how we get through our packed stream very quickly. And if it's a negative, well, we'll plot it, compare it to 240, increment this. But if it's 240, like F something, that just means we plot a single. So we plot it, and then we loop back and go get the next one. But when it's somewhere between 128 and 239, well, that's the only time it drops below, at which point we can check, did the Y jump over to the next section, the next 128 bytes, at which point this will increment the data pointer here, and we go deal with another section. We have 8 of this in a row. This type of code is repeated 8 times for each little part of the color RAM. Say we have a value of 158. Well, it's not negative here, and this will fail, so it comes down. Now we'll strip out the high bit, and this becomes now the target. It's a self-modifying code. The branch is based on how many repeats we need. Now, 158 doesn't mean much, especially even if you strip out this. But the trick, this is where things get crazy. It's actually carefully constructed back in the rollout stage. 158, it might lead it here because it writes the branch target of where it's jumping. And from there, we just plot that many. And then we increment and go back. It's very, very specific and very carefully constructed. And then we have one of these for each of the 8 each of the 8 sections of the color RAM has its own unique pattern, right? Like, 9091, 92, 93, and it goes on and on. Yeah, so as you can see, it's rather confusing, but I do have code that generates this for me, and with careful plotting and planning, you can make sure you're going in with exactly how many repeats you need to do. And as you can see here, it only goes as far as, we can't go into the negatives because we're stripping out the high bit. So the highest that you can actually go is 906F. These are not directly accessible out of the gate because things that end in 7, for instance, like 7 something hex, is actually F something hex, which means do one and go back. So yeah, this is kind of confusing, but now that I got it, it's hella fast, but it might not be what I end up using in the very end, but I am on the right track with this. So let's get back to the video. Wasn't that informative? I have no idea because I haven't made it yet. But anyway, so here is that quote latest one, even though I now have an even better one on paper, which I may not need. But anyway, long story short, this is what I was dealing with, and it was pulling my hair out. And check it out.
May?
Okay, now that works properly. Now let me get it queued up again, and this time I won't disable the color unpacking. Oops, I assembled it and it still had the skip color unpacker, but it's gone now. So this is what I have to deal with. What volume are we at? Okay, you ready? How fun is this? Yeah, I'm screwed. Now, I was going nuts trying to debug this. I've re-rolled it at least twice, trying to get different things ready. I thought maybe my packer, like the rollout itself, was flawed. It turned out it wasn't. The problem lied in my own code, and I looked at it carefully, and as you do, you read more and more into it. Now, well, you've seen this long enough. Let's move on to the next bit. So lines 7200 to, well, 7350 deals with the first 128 bytes of the color pack. Now, I fully commented them. If you don't want to listen to me talk, pause it and take a look. But what you see there at 7305, it masks out like the packed byte. Now, I've already explained how this works in my little cutaway video, whatever you just saw me talk about. So the 7305, that masking of the bits, did not occur, you see, at 7505, it wasn't there because I was stupid and I was going to have part of the routine at 9,000 and part of it at 9,080, but I went to 9100 instead. However, I made that flaw, right? So 7505 does not have an AND 127. I have it here because that's how I expected it to do it at 7705, right? This one, 7905, it's missing. It's here, 8105. It's missing at 8305. You catching on? Now take a look at line 8320. Load data, comma y, whatever, right? 7, it's in proper place, 8520, load data, whatever, yep, okay, good. 8, 8705, there's no and 8720 has load poi, not data. And that was yet another of the flaws. So once I put those ands in place and changed line 8720 to have the data in it, fixed enough, and it works. So what I did was, so here's my raster interrupt, and the new frame is introduced, well, somewhere down here. 6640 is the coloring. So I ended up putting in, after I had it working, I had the brilliant idea of my usual color thingies. 6630, increment DO20, 6645, decrement DO20. And the result is this.
May?
Yes?
You're pretty busy looking this way and that way, kiddo.
Where's that to make sure nobody...
Okay, now this is, remember, this is my somewhat dangerous, quote, faster color unpacker. So as you can see, when the scene changes, watch how low, see, look at that. The white was coming all the way down to here, and there it was again. Only when the scene changes is it really taxed, because I do have special code in place to look for strings, like streams of the same color to plot. And as you saw with the breakdown of the code, it can plop them down pretty quickly. However, today, like I was working on a new section of code that I think is even faster in the long run, but I haven't implemented it yet. And if I do, I got a feeling it's going to be faster. But at the moment, what you see here is it's a success. I could literally wrap up this project tomorrow afternoon, and it's all over. It's done, it's done, it's done. So while I was happily checking out my new color packer, I was playing this version and that version and checking out the differences in the all-important berry zoom and seeing how far down the white goes. I ended up running into a different anomaly that kind of caught my attention. Now you might see it here in a couple of the versions, and yeah, so Now we have a bit of red in the tree and a little bit of green on the goat herself. I couldn't figure this out. I mean, I haven't gone too deep into timing and testing and stuff, but I'm like, this should be fast enough to catch this. Why is it doing that? And I mean, this is frustrating to the max at this point, but I thought about it and I'm like, I suspect, because on the one I'm pointing at now, this is the one where I don't do the code that you're about to see on the screen. This particular section here is where I take, if it finds something it needs to plot and something else it needs to plot, and the one in between is blank, do this, fill it in, so you can just do a run of 3. And supposedly that might save time. It may or may not. It's a close call. But I mean, if there's like X blank, X blank, X, it can, over time, string them all together. And I'm thinking the berries sequence, where zooming in on the tree, there's a lot of those little blanks. But this code is flawed. Now, I'll explain briefly here. We take, this is the packed buffer. This is the things that we've already compared, last frame to current frame. Anything that's different makes it into the packed buffer. So we're examining the packed buffer, things that have yet to be plotted. If we take what's there and put it here. If it's nothing, we go forward. I mean, this is a lot of increments, decrements of y. It's stupid, but I'm basically keeping track to 125, because 125, when we get to 125, we cannot do any more, because we can't have a 1, 2, 5, 6, 7 combo and plot those together, because 127 is specially flagged to move on to the next. Anyway, if there's something here, something at all, and we compare it to 2 pieces forward, if it's the same, if it's not the same, we skedaddle. But if it is the same, then we go back 1 and we look at the piece in between. And if it's blank, if it's not blank, we skedaddle again. But if it is blank, we take what we plotted and put it in the middle. So we get XXX. And I thought, oh, this is very clever. But what I didn't realize until, a few minutes ago is this is blank only because the last frame and the current frame match. So the current frame might be a completely different color in this middle part. But by doing this particular logic, you are now changing that. And that is probably why the goat is getting bits of green on her when she doesn't deserve it. The tree has a bit of red. And I've noticed bits of white and yellow throughout the video. Just occasional squares that kind of made me shake my head. So what I'm going to do, even though I don't plan on using this in the end, I am going to change this code and correct it and re-roll it out tonight, because that's going to take, most of the time I'm sleeping, so what? And it only takes about 2 hours to add the color in the morning, and then I can see if this fix is truly a fix. Because I still have stuff on paper. I can't even show you, it don't matter. But yeah, so I'm going to get back to work here. Just get this thing started. Because even though I don't plan on using this, who knows, maybe I will. But there's a satisfaction in squashing it once you discover it. And I really can't let that go. So yeah, you're toast. I'm going to fix that. And here's the fix. Well, I made it a little more understandable. I got rid of all the monkeying around with Y, and I just put a save the temp and load it when you're done. But as you can see now, we check if there's something here and it matches this, and the middle piece is not flagged to be packed, but it actually perfectly matches what was already there, then we plot it as packed as well. The thing is, I have to do some bit stripping because the last frame and the current frame are just 4-bit colors, like up to F, and yet the packed flags have like F something, because the F stands for hey, plot me. So yeah, you can see that it's a little weird, but this should work fine. And I'm going to assemble this and get this thing running, and yeah, I'm done for the night. And there we go. This might be the very last video rollout I do on this project, but I can foresee that it's not, because just when I think I'm done, something else pops up. But hey, this might be it. This might really be it. All right, the video rollout completed overnight. The audio rollout successfully finished this morning. All I have to do, if I really want to wrap this up, remove the debug coloring and we're done. But I still have that better color unpacker on paper, which means I would have to actually tweak my rollout a bit and re-roll that just to try it out, just so I can get the sections of the border that's white to be less. And that, if that is a success later, I might have the possibility of upping the audio rate from 8 kilohertz to 11. But first of all, I'll show you. I got it done. This plays flawlessly. Take a look.
May?
Yes?
You're pretty busy looking this way and that way, kiddo.
We've got to make sure nobody's watching us. We can't be seen together. We have to be on the lookout. Ah!
What?
Look over there!
What? What is it?
Berries! There! Look at how red they are!
Yeah.
Now, as you saw, or you might have seen, the goat had no interference on her body because, yes, the fix that I did last night was the problem. Well, this is April 30th, 2024. This is the last day of the month, of course. I said I could do this finish this in April, and that is likely going to be true. I mean, I could take this diversion and check out this different, stronger color unpacker rollout combo. But if I want to be done, I am done. This is just extra credit now. Upping the audio rate to 11 kilohertz would be a big win, would it not? Like, wow, 24 frames a second with 11 kilohertz audio at 1 megahertz. Wow, that's what I'm going to shoot for. Later this afternoon. I'm hungry. See you guys. And so I got this new color thing working rather well, and yet it's already outdated because in the next episode I want to try something different. I think I have a faster way of doing it, and well, the urge to try that out is kind of irresistible for me. So until next time, I'm Loop Darks now.